Okay, so my name is Marko Pogrebisky. I'm from Checkmarx, sales engineer from Checkmarx, and today I will be talking about supply chain security and some challenges and some solutions in this space. So just a show of hands, how many of you guys heard the term supply chain security? Supply chain risks. Okay, so not too many. So let's get into this. So first of all, it has been identified as a problem, and this is just a quote from Gartner regarding this. But basically, what it says in essence is that once something that was considered as a more or less a theoretical threat, theoretical risk, has recently become a big issue. So lots of recent attacks have been actually a result of supply chain exploits, and we'll get into some of these examples in this session. And this is a quote from one of the prominent individuals in this space. So basically what it says is that you need to have some defenses against supply chain attacks as a part of your DevSecOps strategy. It even was acted upon by the US government, and as a part of the executive order, there is a directive to include improving software supply chain security as one of the measures to take care of overall cybersecurity. Okay, so how and why? So first of all, what's software supply chain? If you think about this in today's world, in the world which is driven or run by software, there are strong parallels between the traditional world supply chain and software supply chain. So you can see, there are some analogies between the traditional world, the material world, and the less material world, but still very influential world of software, different bits and pieces. Yeah, and as you build cars with some kind of a, some kind of automated process, the same applies to software. So in the world of software, you have this kind of process where developers develop code, it gets into the source repositories, it then gets built, and you have dependencies that are injected at this stage, and then you produce packages, and then these packages are deployed and consumed by the consumers. Now, if you think about what are the stages where risks can arise, there are many stages here. So, and there is a consortium which these vendors came up with. It's called SALSA, or Supply Chain Level Software Artifacts. As you can see, many big names are there. But what they're trying to regulate, they're basically trying to identify and regulate different stages of the software development process, and identify threats on the way, and see how these threats can be remediated. Now, what's important to understand here is that the top part of it, this part, are basically under the full control of your organization. Okay, so from the size of perspective, they can put lots of controls there. You can see some examples there. You can secure the developers' workstations. You can enforce multiple MFA on repositories like GitHub, etc. But the idea here is that it's under your full control. What's less under the organization control is the dependencies, or what goes inside these dependencies. Because at the end of the day, these dependencies are created by third parties. Okay, so everyone loves using open source. Why is that? And yeah, and by the way, 90% of the code in your applications comes from third parties, from open source. So why is that? It's because developers want to develop fast, right? They don't want to reinvent the wheel. Every time they need a piece of functionality that someone else has already created, they would rather reach out and find a component that does it and use that component. right? Before you sit down and write a piece of code, the first thing that you do, you try to find that someone else has already done this. Okay? Now, one of the challenges here is what we call the dependencies of the dependencies. So let's say that you want a piece of functionality and you found a package, and this package, you started using that package, okay? So this is what the developer asks for, a package, okay? Now, what he didn't ask for is another package. It's not just one. That's what he ends up with, right? So you ask to install to bring in one package, you end up with bringing dozens, sometimes hundreds, sometimes thousands of different packages. So just an example, you install a package called cnc.js. You end up with installing 800 additional packages because of the dependencies of the dependencies. Okay, this is how these mechanisms work. You know, you have one package that brings another package with it, and it goes on and on. So you end up in a jungle, and it is a scary world out there. Now, if you look at the dynamics of how many packages are getting released, you can see that the trend is only upwards, with some exemptions of maybe Ruby, but with most of the other environments, the trend is definitely upwards. So there are more and more packages being released for every runtime environment every year. If you just look at NPM, which is one of the most popular package platforms, you can see that there is over 500,000 of package releases every month by now. So it is really a jungle. Now you have this efficiency dilemma. Should you be using open source or avoiding open source? But in fact, it's not a dilemma. The dilemma is already solved. Everyone is using open source. You can't really avoid this. You just need to make sure that you use the right components for your software. Now, for some reason, and if you think logically about this, it's difficult to explain, but people tend to trust open source. Why is that? Well, first of all, it's open for everyone to look, right? But let me ask you a question. Have you yourself looked at the actual source code of the packages that you're using? Probably not. Now, there is another concept here. If there is an issue, someone will notice. Okay, but if everyone thinks this way, then nobody notices, right? Now, there are some scoring mechanisms, but these mechanisms can actually be cheated on. And I'm going to show you an example how this can be done. And in general, it gives you a trustworthy feeling. So this is an example. The component on the right is the real one. Now someone went and created another component with a slightly different name, pointed to the same source repository, and basically created the clone component, which had not just the look and feel of the original component, but it also inherited the star rating from it. Because you pointed to the same source repo, and the system there, in this case it's pip, it just picked the star rating from the source and assigned it blindly without any cross-checks. This is how it works, okay? So which one is the real one? You can't really tell straight away, right? Okay, so everyone can contribute to open source, even attackers. So here is an anatomy of an attack. So meet this guy. His name is Faisal. He's from Turkey. And he's a good member of the community. So this is a component that he developed and is still maintaining. Its name is UA-parser.js. It's a part of Node infrastructure. Used a lot, so maintained over 10 years, 10 million weekly downloads, used by millions, including Facebook. Would you use it? Yes, no? Well, the answer is you're probably already using it. Because it's somewhere out there, you know, one of the dependency of the dependency, okay? Now, on October 5th, 2021, there was a message going on the Russian underground chatter selling someone's account credentials. So basically just offering it for the higher bid, for the highest bid. Starts from 10K USD. Everyone could grab this, okay? So this happened on the 5th of October. A couple of weeks later, Faisal went public and basically said, look guys, I'm really sorry, my credentials were stolen. And someone published packages on my behalf. And these are the version numbers, but that was not me, okay? So someone bought his credentials and started pushing packages into under his name into NPM. Versions of this UEParser.js package. Okay, so this is the actual offensive code in there. As you can see, it actually runs a crypto miner. So it basically tries to utilize your computing power to mine some cryptocurrency and sending it to some crypto address. And incidentally, it uses Monero, which is the kind of cryptocurrency which is not traceable. So they covered their tracks really well. Okay, so a couple of weeks later, there were another couple of packages. So one of them was Koa and another one was RC. And they're not related. They're developed by different people, different contributors. But what was, and again, these packages are widely used, as you can see, lots of downloads, etc. But they use the same malicious code. So they could actually establish the connection. It was probably the same party, the same hacker who used the stolen Faisal's credentials, but then used the same code to poison other components. And we still don't know how exactly they were able to get into these components. Okay, so you can see over the course of just 1 month, from the moment someone's credentials were stolen, just in just 1 month, not just that component was infected, but a couple of additional components were infected, and the number of consumers of these components is probably, by that point in time, was already in the millions. Okay, so that was one example. Now we have another example. So this is another member of the community. Again, good guy, good contributor. So the component that he develops is called, well, he actually develops a number of components, 41. But the one of interest, so he's making a positive impact, but the one of our interest is Node IPC. Okay, it's also part of Node infrastructure. And again, very well-regarded component, maintained for over 8 years. 1 million weekly downloads. So again, something that you would really trust. And again, most likely you're already using it anyway. Okay. So on March 7th, 2022, that's what, 3 months ago, 4 months ago, he added some new functionality. So this is the piece of code that he added. Can you make any sense out of it? Well, one thing you can say for sure, he was trying to cover what he was doing here, okay? Because he basically created a bunch of code here which looks cryptic, base 64 encoded, most likely trying to hide what he was doing, not just from people, but also from, for example, static code analysis tools, because otherwise they would have picked it up. Okay, so after you decrypt it, this is what you see. Okay? So some interesting stuff going on there. So first of all, it's calling Geolocation Api. So basically, this API gives you an understanding where this code is running at runtime. Okay, so this is an example of such a request. You can see that amongst other things, it also gives you the name of the country. Okay, then it was comparing if the country name was either Russia or Belarus, it would do this. Okay? So basically doing damage if the code was run in Russia or Belarus. Now, why is that? Yeah, and also this is not in there, but it was replacing the deleted file with love heart. Okay? Okay, so why? Well, the answer is obvious because of the war in Ukraine, which started just a couple of weeks before that. And this was Brandon's way to protest against it. So it was not a hacker. It was him himself spoiling his code, essentially. Okay? So there is a new term called hacktivism, or another one called protestware. And basically he's saying, okay, it's my code, I do whatever I want with it. I decided to do this because this is what I feel, this is how I feel, and, take it or leave it, basically. Now, what can you do? Not much. And, it looks something that might not affect you today, but who knows what comes up to his mind next time, or someone else's mind. Because anyone can do this, and for whatever reason, and they can do whatever they want. So then the question is, yeah, and obviously there was a backlash, lots of people were angry about this. So what do you do with his other projects? Do you keep trusting them? It's a good question now, right? Because he has 41 packages that he's developing, and he did it only to one. Okay, so it's a good question. So now we're coming to the solution side of things. So software composition analysis is definitely a part of the solution. So a good software composition analysis tool adds security. It basically helps you to align security and operations. It gives you an understanding of your open source risks. You can triage and stuff like that. You can prioritize remediation using the exploitable path. So all this is the traditional software composition analysis, which is mostly focused on vulnerabilities. Okay? But the next generation software composition analysis must include supply chain. Because basically we're looking at the same type of artifacts. We're looking at the dependencies, and we're trying to understand whether these dependencies might be maliciously constructed by parties like this. And again, it could be a result of someone stealing credentials or a result of someone going, crazy about some idea. But in essence, if you look at the evolution of software composition analysis, we're getting to the stage when it has to include supply chain security. Yeah, this is just an example of how an analysis of such a package would look like. So this is an example of supply chain security risks reported by our software composition analysis. And this is an example of this UE parser and how it was reported. So just at the very end, what I wanted to kind of highlight to you, when it comes to the solution, so as I said, it's a part of software composition analysis, yes, but how do you make sure that you actually get the right information into it? So from our end, what we do, we actually have a group of people or on the constant lookout, and they're looking just for new maliciously constructed packages out there. Now, they're doing it by looking at different repositories, looking at contributor reputation. So if, for example, if someone published a component into a piece of code that has been developed by other people. They try to understand, what's the reputation of that contributor and stuff like that. They also do behavioral analysis. So for example, if there is a component that, for example, opens ports for listening or tries to reach out to local file system or local network, this will be detected by this behavioral analysis. Okay? So there is a big operation behind the scenes. At the end of the day, when it comes to the reporting, if you use, for example, our software composition analysis, and by any chance you've got one of these components into your supply chain, you will see the result. And it will just be, one line in the results. But there is a lot of work going behind the scenes for this to be available. Okay. So that was all from me. Any questions? Yeah.
Yeah, the code there was base64 encrypted.
Mm-hmm.
How was that found?
It was found because someone actually has done behavioral analysis. You see that there is this behavioral analysis there, which uses both static and dynamic. So basically, we have a component which is called, we haven't released it yet, we use it internally, it's called Detonation Chamber. It allows you to instantiate a component and run it. And then basically by looking at, it's kind of a sandbox. So when you see that, for example, it tries to access this Geo API, that already kind of raises a flag. Why does it do this? I mean, why is it doing something like that? It's not supposed to do it. And then it started from there, and it raised suspicion, and then people started noticing other things. Because probably it wasn't run in Russia. It was probably run in Israel. But after the initial suspicion was raised, they started investigating.
Looking at the location, which was the red flag, not the encrypting a bunch of code and executing it?
Yeah, it's a runtime analysis. It's actually a runtime analysis. Because you can hide the lines of code, but when it's running, it's decrypted, and then it's actually trying to do what it's meant to do. Okay. Yes?
I was thinking, what kind of rules when you are choosing what packages to include in your project?
Mm-hmm.
Yeah. So just like this supply chain assurance, use some app, and also is there other rules kind of when you decide to use a package?
So the way we implement supply chain security, it's a part of software composition analysis. So when you run your software composition analysis scan, it goes over all of your dependencies, just as is. If you look at this diagram, sorry. It would have probably been easier for me to just find it. Yeah. So what software composition analysis does, not just ours, any software composition analysis, it tries to build this diagram. So basically, what you see in the manifest file is just the first line, right? This one. But what you don't see is all this jungle. So what software composition analysis does, it does the dependency resolution. And then for every component found, it goes and checks against the database what's the latest information available for that component.
So
okay.
If there's any vulnerable things in some of the packages, just don't use it.
Yes, yeah. If it's an infected package, if it's unlike packages with vulnerabilities that you might think, okay, I may still use it because there is no better thing to do. With these packages, with the malicious packages, you just don't use them. That's it. It's as simple as that. Yes, yeah. Yes, exactly. Yeah.
Because originally I think many companies just say, okay, if many people are downloading this package, we just use it, and it's very convenient to use
If it's an infected page, think about this as a virus, okay? Would you use the virus? No, you won't use the virus. I agree that it's a bit confusing because with software composition analysis, sometimes you get hundreds of results, and like with every risk, you do the risk assessment, right? You look, okay, this looks like, high risk, then I remediate it first. This looks like low risk, I'll probably postpone, put it in the backlog and stuff like that. But not with these components. With these components, you get rid of them straight away. Okay? Any more questions? Okay, thank you very much.